Welcome, dear listener, to another quiet evening beneath the soft expanse of the universe. I'm glad you're here, settling into a gentle moment of rest as the world around you begins to dim. Tonight, we will drift together into the peaceful reaches of deep space, where two small travelers, Voyager 1 and Voyager 2, continue their slow, eternal journey through the galaxy. Their motion is calm, their purpose steady, and their presence among the stars offers a kind of comfort that seems tailor-made for nights like this. As you listen, you're invited to let your own thoughts drift just as easily, as though carried on the same quiet currents that guide these distant probes. Before we drift too far into the cosmic night, feel free to like, subscribe, or leave a gentle comment if you'd like to support the channel. You can do it now, before your eyes grow heavy and the Voyagers lull you into sleep. This space is meant to soothe you, and your support helps keep these peaceful journeys going. Let's begin. The universe opens before us, like a great, dark ocean, a place where scale stretches beyond imagination, yet somehow invites us into a deeper sense of calm. Out in the quiet, where sunlight fades into a faint, faraway shimmer, the Voyager probes continue to sail, as though carried by the softest tide. It is hard to imagine now, but they began as small, bright sparks of human effort, launched from Earth in 1977, during a moment when the planets aligned in a rare, elegant arc. This alignment allowed the probes to visit world after world, like beads on a cosmic necklace, borrowing gravitational energy from each planet to slingshot themselves farther outward. It was a brilliant piece of engineering, but also a gesture of hope, an attempt to touch the wider universe with instruments no larger than a modest household appliance. In their earliest days, the Voyagers were bathed in the familiar warmth of the sun. They glided through the realm of the inner planets, where sunlight still glows gold and strong, and where the whispers of solar wind curl around the planets like soft threads of breath. As they journeyed outward, they passed the orbits of Jupiter, Saturn, Uranus, and Neptune, worlds so massive that their gravity acts like gentle hands, guiding the probes onward. The Voyagers recorded swirling storms the size of Earth, rings sculpted from icy dust, and moons marked by volcanic heat or frozen surfaces that shone like glass. These worlds were old and immense, yet the probes drifted past them with a kind of respectful quiet, as though trying not to disturb ancient beings that had circled the sun for billions of years. Over time, the sun's pull weakened. The Voyagers continued to move outward on the momentum of their earlier push, sailing into regions where sunlight faded into a soft glow, a distant lantern slowly receding behind them. Astronomers sometimes describe this zone as the outer porch of the solar system, where the familiar warmth of the sun begins to thin into the cool, delicate airlessness that surrounds the entire Milky Way. Even here, the probes felt the faint touch of the heliosphere, the great protective bubble carved by the solar wind. The heliosphere is like an invisible atmosphere around our star, stretching beyond the planets in a shimmering teardrop shape. Inside it, charged particles from the sun flow outward. Outside it, the interstellar medium surrounds everything, made of ancient star-crushed dust and atoms drifting far apart. Long before either Voyager reached this boundary, scientists had wondered what crossing it would be like. They imagined it not as a barrier, but as a gentle threshold, the moment when human-made objects moved from the familiar influence of the sun into the quiet of true interstellar space. When Voyager 1 finally crossed this boundary in 2012, about 121 astronomical units from the sun, the event felt less like a crossing and more like a soft exhale. Instruments detected changes in the density of charged particles. The rhythm of plasma waves shifted, and somewhere aboard that aging craft, a signal pulsed outward at the speed of light toward Earth. Even traveling so quickly, the message took more than 17 hours then, and over 22 hours today to arrive. Imagine a whisper so faint and far away that it needs nearly a full day of light-speed travel just to reach home. That is the scale of Voyager's journey now, and thinking about it can make your mind feel pleasantly spacious, as though inner clutter begins to drift apart and settle. Voyager 2 followed in 2018, exiting the solar bubble at a slightly different angle, drifting like a second seed carried on a separate breeze. The two probes now move outward in different directions, each describing its own long, graceful arc through the galaxy. They are so far from each other that they will never meet again, and yet together they form a pair, two emissaries from the same small world, released into the endless quiet with a sense of purpose and patience. They no longer feel the tug of planetary gravity or the steady wind of the sun's particles. Instead, they sail through a region where atoms float so sparsely that a cubic meter of space might hold only a few dozen of them. This kind of emptiness is gentle rather than harsh. There is no turbulence, no storms, no collisions, only a calm, uninterrupted glide through what some astronomers poetically call the galaxy's deep breath. Out in this region, space behaves differently than the environments the probes once knew. The interstellar medium resembles a mist so tenuous it is almost a metaphor, yet its presence can still be felt through delicate vibrations and the subtle resistance it offers to charged particles. Voyager 1's plasma wave instrument continues to detect the background hum of this environment. Each reading is like a faint ripple carried across a still pond, a quiet indicator of density, temperature, and cosmic history. When Voyager 1 experienced a memory glitch in 2024, scrambling its telemetry like a dream made blurry at the edges, engineers on Earth spent months coaxing it back to clarity. They described the process as a careful dialogue with an old friend, a machine that still responds when spoken to softly and with patience. As the Voyagers drift farther, their signals grow weaker. Engineers must listen with enormous radio antennas spread across the world, quiet ears pointed at the sky to catch every faint syllable. These signals are fragile, but even so they continue to arrive. Each transmission represents a triumph over silence, a testament to the idea that distance does not erase meaning, only softens it, and that softening is not unlike the slow relaxation that settles into your own body at night. Take a slow breath if you wish, and allow that parallel to settle, the way messages fade with distance, the way thoughts fade with time, the way the body gradually releases the day as you drift toward rest. What makes the Voyagers so soothing to contemplate is not just their distance, but the way they embody patience. Their speed, about 17 kilometers per second, feels immense by human standards, yet out in the galaxy, this motion is nearly stillness. Over thousands of years, they will adjust course only slightly, influenced by faint traces of gravity from passing stars. Their path through the interstellar medium is like a leaf floating on a pond, so calm it appears motionless unless watched for an impossibly long time. In this vast expanse, time stretches and softens. Moments lose their urgency. The universe shows no hurry, and in this absence, we feel permission to slow down as well. Their nuclear power sources, fueled by decaying plutonium, gently diminish with every passing year. The warmth produced by this decay has always been enough to keep their instruments alive. But gradually, watt by watt, the energy fades. This fading is not abrupt. It is gradual, predictable, and serene, like a lantern's light slowly dimming as night deepens. Engineers on Earth have been turning off instruments one by one, preserving precious power just as someone might conserve the last flickers of a candle. There is something soothing in this process, a reminder that decline can be gentle, and that even as functions retire, purpose remains. While we continue tonight's journey, imagine the view from Voyager's perspective, the sun reduced to a bright star among billions, the Milky Way stretching like a pale river across the darkness, and silence so complete it becomes its own form of music. The probes drift through ancient material atoms that once belonged to long-destroyed stars, particles older than Earth itself. These remnants float in a vast ocean of emptiness, and the Voyagers move among them like small boats tracing a path through an eternal tide. As you imagine this view, allow your thoughts to soften around the edges. There is no urgency in space, no deadlines, no noise, just motion so steady it becomes a kind of stillness. If you sense your mind loosening its grip on the day, that is all right. This script is meant to gently carry you, just as interstellar space carries the Voyagers, step by step into deeper calm. Humanity's presence aboard the Voyagers exists through the golden records, those shimmering copper discs engraved with greetings, songs, music, and the rhythms of our planet. Even now, these records remain attached to the probes like talismans, drifting through starlight. Their grooves preserve voices and laughter, the thrum of a heartbeat, the collective breath of oceans and wind. They hold fragments of Earth's melody, destined to outlast mountains, continents, even the sun itself. While life on Earth continues to change, languages shifting, forests rising and falling, generations passing, these small records continue onward, storing a memory of who we were at the moment we reached out to the stars. And somewhere in that thought, a gentle truth resides, that we, like the Voyagers, are always drifting, not lost, but carried by currents older than memory, currents of time, circumstance, and quiet wonder. As we move deeper into this story in the coming parts, you will find that the Voyager's path is not just a scientific journey, but a peaceful metaphor for the quiet unfolding of existence itself. For now, feel free to let your breath become a little softer, your shoulders a little lighter, as we drift with these tiny travelers beyond the boundaries of the sun's bright influence. Their journey continues, steady and serene, and tonight, it invites you to rest in the same quiet. The Voyagers drift farther now, leaving behind the sun's soft but familiar glow, and entering regions where light becomes almost symbolic, more memory than presence, more echo than flame. In this new realm, the probes continue to glide with a patience that feels almost meditative, as though their motions were meant to teach us something about the quiet pace of the cosmos itself. There is a deep serenity in imagining their position at this very moment, far beyond the orbit of Pluto, beyond the distant Kuiper belt with its icy, dimly lit objects, and beyond even the scattered disk where debris from the early solar system still follows the faint tug of our star. Out here, the distinction between belonging to the sun and drifting free becomes delicate, softened by distance and the natural thinning of influence. Yet the Voyagers remain steady and untroubled, moving through a landscape that stretches thousands of times wider than the space they once knew. The solar wind, once strong near the planets, has now faded behind them, becoming a memory they can no longer feel. Instead of being brushed by the constant flow of electrically charged particles from the sun, they are surrounded by the interstellar medium, a subtle sea of atoms and dust that drift here like wandering relics of long-dead stars. Though this medium seems unimaginably empty by human standards, it is, in a cosmic sense, the true substance of the space between stars. Its particles carry histories written in forces and events far older than our solar system, explosions of supernovae that once scattered heavy elements across the galaxy, ancient collisions between massive stars, and the slow, endless settling of cosmic dust. As the Voyagers glide through this diffuse ocean, they detect these elements only faintly, through instruments sensitive enough to distinguish minuscule changes in charged particles and magnetic fields. And though their instruments grow older every year, they still manage to record whispers of this environment for us, even across distances so immense that their signals fade into a thin thread stretching across the void. To understand where the Voyagers now travel, it helps to imagine the solar system not as a cluster of planets orbiting the sun, but as a vast bubble inflated by the solar wind. This bubble of the heliosphere is shaped somewhat like a comet, rounded on the side facing the star and stretched into a long tail on the opposite side. Its boundary, the heliopause, marks the place where the pressure of the outward blowing solar wind balances the inward push of the interstellar medium. Crossing this boundary is a milestone, but not a violent one. There is no wall, no barrier, no edge glowing with bright energy. Instead, the transition resembles stepping from warm, sunlit shallows into deeper, quieter waters. Voyager 1 felt this shift when it detected a sudden change in particle density, and its plasma wave instrument registered new frequencies, like a change in the pitch of a distant tone. Voyager 2 experienced this same transition 6 years later, drifting across the boundary in its own direction. Together, these crossings marked humanity's first physical step into the space between stars, a place that had existed since the dawn of time, yet never held a trace of our presence until those quiet moments. As the probes drift onward, their trajectories remain nearly unchanged. With no planets ahead of them to provide gravitational boosts or alter their paths, they travel mostly under the influence of their original momentum. The Sun's gravity extends infinitely, but becomes weaker with distance, and the force now acting on the Voyagers is extraordinarily faint, like the soft pull of a memory trying to hold on. In a few tens of thousands of years, the probes will pass near other stars, each journey shaped only by the gentle curves of celestial mechanics. Voyager 1, for instance, is headed toward a faint star called Gliese 445, located in the constellation Camelopardalis. When it approaches this distant neighbor in about 40,000 years, the star will not look particularly remarkable. It will simply be another point of light, shifting slowly across the background of the galaxy, but to the Voyager probe, it will be the next closest sun in its long path through time. The scale of this journey of 40 millennia to reach a single star can feel almost ungraspable. On Earth, 40,000 years ago, early humans were painting in caves and walking across continents, shaped far differently than they are today. To imagine that same period stretching into the future, with Voyager traveling through cosmic darkness the entire time, invites a softness into the mind, a recognition that time, like space, becomes gentle when viewed from far enough away. The probe will not hurry, it will not slow down. It will simply drift through epochs, a patient traveler untouched by the short rhythms of daily life on Earth. While the probes move forward, their instruments continue to fade very gradually. The nuclear batteries that power them, called radioisotope thermoelectric generators, rely on the steady decay of plutonium-238. Each year, the decay produces slightly less heat, and the conversion of that heat into electricity yields slightly less power. Engineers have known this from the beginning, understanding that these batteries would last only a finite number of years. Yet even with this knowledge, the Voyagers have exceeded all expectations, living far beyond their original missions. Now, as the power dwindles, instruments are turned off one by one, not out of urgency but out of mindful necessity. Each deactivation feels like a quiet dimming of lights in an old house at night. Not a loss, but a gentle step toward rest. The power levels fall low enough that the probes must prioritize their most essential systems. Cameras, once vital for exploring the outer planets, were shut down long ago, but other instruments like plasma detectors and cosmic ray sensors still whisper their measurements to Earth when the timing aligns. These signals, faint and delicate, travel across the void for more than 22 hours before reaching the deep space network antennas that listen for them. The receiving dishes must be pointed with extraordinary precision, and the incoming signals are so weak that they arrive billions of times fainter than the energy of a single snowflake landing on Earth. Yet they are still readable and still full of meaning. Engineers often describe interacting with the Voyagers as communicating with elderly companions, machines that carry the history of decades of exploration, yet still respond with the patience of age. When Voyager 1 experienced a memory malfunction in 2024, its telemetry became scrambled, creating data that looked like the fragments of a half-remembered dream. It took months of careful work to understand and correct the problem. Commands were sent slowly, with time allowed for each to cross the immense distance and for its response to return. Working at this scale teaches humility. There is no rushing, no instant correction. Patience is required, and the engineers, like the Voyagers themselves, learn to operate at the rhythm of deep space. This rhythm is slow, deliberate and forgiving, begins to influence the imagination as well. Thinking about the Voyagers drifting through the interstellar medium has a way of relaxing the mind, as though the vastness creates room to breathe. Allow your shoulders to soften if you'd like, and imagine the probes sailing through the cosmic mist at a pace so steady it feels timeless. Their journey is unhurried. They carry no burden, no weight of expectations. Their role now is simply to exist, to drift, and to endure. As we follow their path in thought, the darkness surrounding them becomes a kind of comfort rather than an emptiness. It is a darkness filled with starlight so faint that each star appears like a tiny pinprick in a velvet cloth. The Milky Way arches overhead, a soft band of luminosity woven from billions of distant suns. The probes move through this tapestry in silence, so complete it becomes almost tangible. There is no sound in space, yet the absence of sound is its own kind of presence. In this quiet, the probes drift like autumn leaves floating across a calm lake, carried by currents too subtle to see. To deepen the sense of stillness, consider the interstellar medium more closely. This medium, though far thinner than any vacuum humans can create on Earth, is not empty. Its particles, mostly hydrogen, some helium, and traces of heavier elements were released by stars that lived and died long before our Sun existed. When Voyager's instruments detect increases in particle density, what they measure are the remains of supernova explosions, the slow diffusion of stardust, and the gentle turbulence that arises when ancient material is stirred by cosmic forces. These processes occur on timescales so vast that the human mind can barely grasp them. Yet the Voyagers glide through them naturally, unaffected by the concept of time passing. Occasionally, slight variations in the magnetic field are detected. These variations are like ripples in an otherwise still expanse, gentle motions that reveal how space is shaped by forces we cannot see. The magnetic fields between stars are weak, sometimes only a few microgauss, far less than the Earth's magnetic field. But they play a role in guiding cosmic rays and influencing the flow of charged particles. Voyager 2, with its still functioning instruments, continues to send back data about these magnetic fields. Each report, every measurement, offers a small glimpse into a region that humanity may not visit physically for hundreds of millennia. The cosmic rays themselves, high-energy particles traveling across the galaxy, are another part of this journey. As the Voyagers move farther from the Sun, they become more exposed to cosmic rays that are not deflected by the heliosphere. These rays originate from distant supernovae and energetic cosmic events, and though they pose no threat to the probes, they offer valuable information about the galaxy's energetic environment. Measuring them helps scientists understand the high-energy particles that constantly bathe the universe. Even as its power dwindles, Voyager 2 continues to provide data that enriches our understanding of these cosmic processes. What makes the Voyager's current experience so calming to contemplate is the sheer simplicity of their existence. They no longer maneuver, they no longer adjust course, they simply drift, carried by the memory of their initial push from Earth, and guided by the laws of physics that govern the entire cosmos. Nothing interrupts them. No obstacles stand in their way. They move through an environment where collisions are rare beyond imagining, where the space between particles stretches into hundreds or even thousands of kilometers, and where the temperature hovers just a few degrees above absolute zero. Yet even this cold is gentle, not harsh, as though the universe itself cradles them in a stillness that transcends sensation. This stillness expands when we consider the probe's future. In tens of thousands of years, they will continue to drift through the galaxy, long after their transmitters go silent. Their metal frames, etched by micrometeoroid impacts and bleached by eons of starlight, will persist even as civilizations rise and fall on Earth. In 100,000 years, they may pass through regions of denser interstellar clouds, where dust and gas gather in subtle patterns. In 1,000,000 years, they may drift through the spiral arm of the Milky Way, carried effortlessly along the galaxy's slow rotation. The probes will outlast continents, oceans, climates, and even the languages we speak today. Their endurance is not measured by activity, but by persistence, the quiet ongoing presence of two small machines that embody humanity's desire to reach beyond itself. In the present, however, they remain linked to Earth through their faint transmissions. The Deep Space Network continues to listen for them, using radio dishes in California, Spain, and Australia. These dishes track the probe's positions with incredible accuracy, compensating for the Earth's rotation, the movement of the Moon, and the long arc of the planet's orbit around the Sun. Receiving a signal from Voyager is like catching the softest whisper in a vast room, challenging, delicate, and immensely rewarding. Each message that arrives reminds us that even across enormous distances, connection remains possible. The golden records carried by each probe deepen this sense of connection. These discs, mounted on the outside of the probes, hold sounds and images from Earth greetings in more than 50 languages, music from many cultures, the sounds of wind, rain, birds, and whales. They carry photographs and diagrams explaining our world, our science, our biology, and they hold a message of hope that any beings who might one day encounter these probes will recognize that Earth once existed, full of life and longing, and that we wished to share a piece of ourselves with the galaxy. These records are expected to last for billions of years. Their copper surfaces may become pitted over time, but the information engraved upon them will remain legible far beyond the lifespan of our Sun. This combination of drifting silence and preserved meaning creates a sense of tranquility that settles gently into the imagination. It suggests that even in a universe defined by change, some things can endure, that perhaps endurance itself is a form of beauty, quiet, steady, and resilient. As the Voyagers journey onward, they remind us that progress does not always require motion we can see or measure. Sometimes progress is simply continuing, patiently, without resistance. Sometimes it is allowing the currents around us to carry us in their natural direction. Sometimes it is trusting that stillness and motion can coexist in the same moment, and that both have something to teach us. And as we follow their steady drift in thought, we find ourselves slowing as well, settling into a rhythm that mirrors the cosmic pace. Their journey continues, unbroken and unhurried, and in that continuity there is a deep and peaceful truth, one that invites us to rest a little more deeply, breathe a little more softly, and imagine ourselves drifting too, in the gentle expanse of the universe. The Voyagers continue their slow outward drift, moving deeper into regions where the sun becomes little more than a distant star. Bright, yes, but no longer defining the environment around them. In this vastness, the galaxy unfolds as a quiet panorama, with stars arranged like beads scattered across a velvet cloth. As the probes glide farther from the heliosphere, the familiar boundaries of our solar neighborhood dissolve into the limitless expanse of interstellar space. It is here that their journey becomes something more than an exploration. It becomes a meditation on endurance, on time, and on the serene beauty of distance. Though the Voyagers no longer see planets or feel the shifting pressures of the solar wind, their instruments still sense the faint textures of the interstellar medium. This region, far older than our own star, holds patterns shaped by events long forgotten. Hydrogen atoms drift through these volumes in densities barely measurable, perhaps 1 atom per cubic centimeter. Yet these solitary particles carry stories, tales of stars that lived and died, of nebulae stirred by supernova shockwaves, and of the slow settling of cosmic dust into patterns shaped by gravity. Voyager 2, with its still-functioning plasma instrument, continues to detect changes in particle density. These fluctuations are soft and subtle, like distant ripples across an otherwise placid lake. They serve as reminders that even the quietest regions of space hold traces of ancient energy. The magnetic fields of the galaxy thread through this interstellar mist as well. These fields are delicate, faint lines woven through space, shaped by the motion of charged particles over millions of years. Voyager 2 occasionally detects variations in these fields, offering hints about the larger structure of our galactic neighborhood. To think that such weak force fields 1,000 times weaker than Earth still shape the motion of cosmic particles is to appreciate the intricate balance of the universe. The faintest influences, acting across unimaginable distances, can guide the flow of matter and energy, and the Voyagers, drifting among these influences, become silent witnesses to the subtle choreography of the cosmos. As the probes move farther from the heliopause, they enter a region shaped by the local bubble, an enormous cavity carved within the interstellar medium by ancient stellar explosions. Our solar system, situated within this bubble, drifts through a pocket of lower density gas, surrounded by denser material and interstellar clouds. The Voyagers have begun to sense the contours of this environment, detecting clues about the structure of the bubble's boundaries. Though these details may seem abstract, they help astronomers understand how the Sun moves through the galaxy and how the interstellar medium shapes the environment around stellar systems. In contemplating these immense structures, the mind begins to slow. The scale is so vast, the force is so gentle, that thinking about them feels like floating. Allow your breath to ease into a comfortable rhythm, letting the quiet immensity of space soften the edges of your thoughts. This is the final relaxation reminder in our journey together, and it arrives naturally, like a calm wave moving through the sea of your awareness. The cosmic rays that pass through this region offer further insight. These high-energy particles, accelerated by supernovae and other energetic phenomena, travel across the galaxy at speeds approaching the speed of light. When they encounter solar systems, they are partially deflected by magnetic fields and solar winds, but in the deep interstellar medium, they move more freely. Voyager 1 and Voyager 2 detect changes in the flux of cosmic rays as they drift farther from the Sun. These variations reveal the shape of the heliosphere's protective shield and the nature of the surrounding galactic environment. Although the probes cannot capture images or record sound, their measurements form a kind of sensory map, an abstract portrait of the space between stars. In many ways, these measurements resemble gentle weather patterns. Instead of clouds and winds, the Voyagers observe shifts in particle density and magnetic fields. Instead of storms, they sense fluctuations in cosmic rays. Each faint detection is like a soft note in a cosmic symphony, composed not of sound, but of delicate interactions across millions of kilometers. This method of observation feels appropriate for the setting. In a region where atoms are sparse and turbulence is rare, the instruments record quiet rhythmic movements, so subtle that only machines built with great sensitivity can perceive them. Meanwhile, the probes themselves continue to age with grace. Their power sources, though steadily weakening, remain functional. The interior heat produced by the radioactive decay of plutonium creates just enough thermal energy to prevent the electronics from freezing in the cold emptiness of space. This warmth is faint now, like the last glow of a hearth in a vast, dark room. The steady decline in power has required engineers to prioritize systems, turning off instruments that once played vital roles in the probe's planetary missions. The imaging systems, which captured breathtaking views of Jupiter, Saturn, Uranus, and Neptune, have long been silent. The tape recorders once used to store data have ceased to spin. Yet even as these instruments rest, the probes continue forward, carrying their memories of past encounters and their ongoing connection to Earth. Thinking back to those earlier encounters brings a sense of gentle nostalgia. When the Voyagers passed Jupiter, they revealed swirling storms and lightning bolts hidden within the planet's massive atmosphere. They captured volcanic eruptions on Io and icy surfaces on Europa. They unveiled Saturn's rings with unprecedented clarity, showing intricate structures sculpted by moons and resonances. Voyager 2's later flybys of Uranus and Neptune expanded humanity's understanding of planetary systems, revealing tilted magnetic fields, frigid atmospheres, and winds faster than any recorded on Earth. These early adventures were filled with activity and discovery, yet they led naturally to this current phase of quiet drifting, a transition as smooth as night following day. The contrast between the busy inner solar system and the serene interstellar medium underscores the profound calm of the Voyager's present experience. Near planets, signals from the probes were immediate and frequent. There were rapid shifts in gravitational forces, changes in atmospheric emissions, and encounters with moons and rings. Now, changes occur across vast stretches of time. A slight shift in particle density might take months to observe. A variation in magnetic field strength might unfold over years. This slowness is not a loss, but a transformation. The missions have entered a contemplative phase, one defined by patience and the beauty of persistence. The concept of persistence is deeply embedded in the Voyager's future as well. Their paths through the galaxy will remain unbroken for millions of years. Even when their transmitters fall silent, likely within the next decade, they will continue drifting, Their trajectories will carry them through the galactic spiral arms, across regions shaped by ancient supernovae, and past stars that have not yet formed. They will drift through epochs when human cultures have changed countless times, when continents have shifted, and when Earth itself has transformed in ways we cannot yet imagine. The probes will witness these eras not as observers, but as silent participants, present in the galaxy long after their creators are gone. One day, far in the future, Voyager 1 will pass near Gliese 445, approaching within perhaps a few light-years. Voyager 2, following its own route, will move toward Ross 248, a dim red dwarf that will become one of the closest stars to Earth in about 40,000 years. The encounters will not be dramatic. The probes will not enter orbit or collide with anything. They will simply pass by at immense distances, guided by inertia and the faint pull of stellar gravity. The stars themselves will have moved across the galaxy in their own long, slow patterns, creating a kind of celestial dance that unfolds over millions of years. The Voyagers are part of this dance now, moving to a tempo so slow and vast that it becomes soothing rather than foreign. Along the way, they will carry with them the Golden Record's copper discs, etched with messages, music, and images from Earth. These records, sealed within protective casings, are designed to last for billions of years. They may endure long after the metal frames of the probes have eroded. If another civilization one day encounters them, the records will reveal not just information, but emotion. The sound of laughter, the murmur of waves, the rhythm of a heartbeat, and greetings spoken in dozens of languages. These artifacts represent humanity's attempt to say hello to the cosmos, to offer a gentle message across time and space. Their existence suggests that meaning can be preserved even in the face of cosmic vastness. The Golden Records also connect the Voyagers to Earth in a poetic way. While the probes drift through cold, silent regions, the recordings preserve sounds intimately tied to life: water, wind, animals, music. They carry reminders of Earth's ecosystems, filled with vibrant motion and warmth. Even as the probes sail through stillness, they hold within them echoes of a world teeming with energy. This contrast becomes soothing when imagined carefully. The quiet of interstellar space paired with the living melodies of our planet, drifting together through time. As the probes journey onward, their paths reflect the steady turning of the galaxy. The Milky Way rotates once every 230 million years or so, and the solar system moves along with it, orbiting the galactic center like a boat carried in a slow whirlpool. The Voyagers, now just beyond the sun's influence, drift along this same rotation. Their trajectories are not simply straight lines into the void, but graceful arcs shaped by the gravity of the entire galaxy. In this way, they are part of a motion so vast that the human mind can scarcely comprehend it. Yet thinking about this motion brings a sense of calm, as though the universe itself follows a gentle, predictable pattern. This pattern extends to the distribution of stars around the Voyagers as well. They are surrounded by a sphere of starlight, some stars bright, some dim, most so distant that they appear only as faint glimmers. Over time, new stars will come into view as the galaxy rotates, and the probes move through different regions. Some stars will shift away, fading from sight, while others will grow brighter as the distance between them decreases. This slow evolution is a reminder that change, when viewed from afar, can be peaceful and unhurried. In the present, though, the probes remain threaded to Earth by their faint radio signals. Engineers continue to send occasional commands, adjusting parameters or requesting data. These commands travel across billions of kilometers, slipping through the emptiness at the speed of light. When the probes respond, their messages return with the same swiftness, though softened by distance. Receiving these signals requires immense antennas, carefully tuned to capture frequencies that have drifted slightly due to the Doppler effect, the subtle shift caused by relative motion. Each success in communication feels like a small miracle, a triumph of connection across an ocean of darkness. And yet, the time will come when communication fades. At some point between 2025 and 2030, the probe's power will become too low to sustain their transmitters. The last messages they send will be faint, perhaps fragmented, but precious. After their voices fall silent, they will remain unchanged in their purpose. They will continue drifting, steady and serene, through the deep fabric of the galaxy. Their silence will not signify an end, but a transition, another soft step in their endless journey. Contemplating this future is soothing rather than sad. It reminds us that endings can be gentle, like the quiet dimming of light at the end of a long day. The Voyagers have already outlived expectations, carrying human curiosity farther than any other creations. Their silence will mirror the silence of the space they inhabit, calm, vast, and peaceful. As their journey continues, so too does our quiet reflection. The Voyagers drift through a region where time expands, where movement slows, and where even the smallest particle carries a story billions of years old. Their presence in this space deepens our sense of wonder, inviting us to imagine not just the path they follow, but the serenity that surrounds them. This serenity can settle into your awareness as well, guiding you into deeper rest, just as the probes glide into deeper silence. The cosmic night stretches around them, full of stars whose light takes tens, hundreds, even thousands of years to reach them. And in this slow, shimmering environment, the Voyagers continue forward, patient and unburdened, carried by the ancient forces that shape the galaxy. The Voyagers move ever outward, drifting through the quiet interstellar medium like tiny seeds born on ancient winds. With every passing day, the sun grows a little dimmer in their rear view, though rear view is only a metaphor now, for the probes no longer turn, no longer observe the solar system visually, and no longer adjust their posture except through the smallest, most infrequent commands. Instead, they continue on in the simple, unwavering line determined decades ago, a trajectory shaped initially by their planetary encounters and now maintained by the unbroken silence of deep space. In this stretch of the cosmos, where distances extend beyond comprehension and the nearest objects still lie trillions of kilometers away, the Voyagers take part in a serenity that is almost absolute. It is a curious thought, imagining these probes once surrounded by the busy environment of the inner solar system, now gliding through a realm where almost nothing interrupts their progress. In their earliest years, they traveled past planets with atmospheres swirling in constant motion, moons undergoing volcanic eruptions or tectonic shifts, rings shaped by collisions and gravitational resonances. Near Jupiter and Saturn, the probes were bathed in magnetic storms, energetic particles, and bursts of radiation. Near Neptune, Voyager 2 witnessed winds that exceeded 2,000 kilometers per hour, so fast they seemed to defy logic. But now, out in interstellar space, the conditions around them are almost unimaginably calm. There are no winds, no storms, no eruptions. Even the cosmic rays, energetic though they may be, arrive in patterns that shift only gradually over months or years. The probes have moved from a world of intense dynamism to one defined by gentle constancy. What makes this constant peaceful is the near absence of resistance. In space as empty as this, the probes encounter so few particles that they could travel for millennia without experiencing a noticeable slowing. A single hydrogen atom every cubic centimeter drifts past, so sparsely distributed that the probe's forward motion remains undisturbed. Even within this stillness, though, the probe's instruments continue to offer glimpses into the environment. Voyager 1's plasma wave instrument, though limited in its capabilities, occasionally detects the faint vibration of electrons moving through space. These signals are incredibly subtle, requiring the deep space network to listen with extraordinary sensitivity. Voyager 2, benefiting from a healthier suite of instruments, senses changes in particle density and magnetic fields, each reading adding a new brushstroke to humanity's picture of the interstellar medium. This picture, slowly assembled across decades, reveals an environment shaped by the life cycles of stars. The gas and dust that fill interstellar space are remnants of previous cosmic events, supernova explosions that flung heavy elements outward, stellar winds that pushed particles across vast distances, and gravitational interactions that gradually sculpted the medium into filaments and clouds. These structures form part of the galaxy's architecture, invisible to the human eye, but detectable through the most delicate of measurements. The Voyagers, though small and low-powered, contribute to this mapping in ways no other spacecraft yet can. They are physically present in a region beyond the heliosphere, a place no other human creation has reached. Every piece of data they send back, no matter how faint, expands our understanding of this vast frontier. The idea of a frontier invites reflection. In human history, frontiers often imply boundary edges where known regions give way to unknown territory. But the frontier the Voyagers have crossed is not a boundary of danger or difficulty, it is a boundary of stillness. The interstellar medium does not challenge the probes, it simply receives them. It offers no resistance, no obstacles, and no urgency. Instead, it offers time measured not in years or decades, but in millennia. This sense of long, stretching time begins to shape the imagination, inviting us to contemplate the journey from a perspective broader than our usual frames of experience. Consider the distances the Voyagers now cover. They travel at tens of thousands of kilometers per hour, at an extraordinary speed in human terms. Yet the space they move through is so vast that progress appears slow. To travel even 1 light-year would take tens of thousands of years, and yet this slow progress is perfectly natural. Stars themselves drift across the galaxy at similar paces, guided by the spiral structure of the Milky Way. The Voyagers are now part of this galactic flow, carried along the same broad currents as the Sun and every star near it. When we imagine their slow drift, we are also imagining the rotation of the galaxy itself, a rotation so wide and gentle that it takes more than 200 million years to complete a single orbit. And within this immense motion, the Voyagers maintain their own paths. Voyager 1 is headed toward Gliese 445, though the star will not remain in its current location. Stars move relative to each other, drawn by the gravitational tides of the galaxy. By the time Voyager 1 approaches Gliese 445 in about 40,000 years, the star will have shifted significantly from where it is today. The probe will not arrive at a stationary target. Instead, both it and the star will meet at a point determined by their separate motions. Voyager 2, on its own course, will someday pass within a few light-years of Ross 248 before continuing onward. These encounters are not truly meetings, they are near passes, glances between travelers on their own paths, yet they mark milestones along a journey defined not by destinations, but by persistence. This persistence becomes even more striking when contemplating the loss of power the probes will eventually face. Their nuclear batteries, aging with steady predictability, diminish each year. The warmth they produce keeps the spacecraft's electronics from freezing. Their electricity powers heaters, transmitters, and scientific instruments. As this power dwindles, engineers have been forced to choose which systems remain active. Bit by bit, older components take their final rest. In the coming years, even the transmitters essential for communication with Earth will fall silent, and then the probes will become uncontactable, though far from inactive. They will continue forward, still warmed slightly by the faint afterglow of radioactive decay, still holding the golden records, still following the trajectories set in motion long ago. Imagining this future silence brings a sense of gentle contemplation. Silence, in the Voyager's context, is not an ending but a natural transition. Just as stars dim and planets cool, machines too experience phases of activity followed by quiet endurance. The probes will not cease to exist when their radios turn off. They will simply exist in a new state, disconnected from Earth but still present within the galaxy's vastness. If we think of their mission not just as a scientific endeavor but as a symbol, then the transition into silence becomes profoundly peaceful, a reminder that continuation does not always require communication or active participation. Often continuation simply requires being carried along by the forces that guide all cosmic bodies. This shift into silence also underscores the significance of the golden records. These discs, engraved with sounds and images representing humanity and Earth, will persist far longer than the data transmissions the probes currently send. They are durable, protected against microscopic impacts and cosmic radiation. If an alien civilization encounters them one day, whether in thousands, millions, or billions of years, they may find within them a snapshot of a world long past. They may hear whales singing across Earth's oceans, or the laughter of children, or greetings spoken in dozens of languages. These sounds will have outlasted the civilizations that produced them, enduring deep into cosmic time. And even if no one ever discovers them, the mere presence of these records on the probes offers a gentle, profound truth. Humanity once reached outward, hoping to share something beautiful with the universe. These records serve as quiet ambassadors for Earth's living systems as well. Within their grooves are the sounds of rain falling, birds calling, wind brushing through grasses. They preserve the rhythms of a planet full of movement and life rhythms, very different from the stillness of interstellar space. The contrast between these environments emphasizes the uniqueness of Earth, a world shaped by cycles, seasons, ecosystems, and life itself. As the Voyagers drift through cold emptiness, they carry reminders of warmth, water, and breath. This juxtaposition is both poetic and grounding, connecting the quiet vastness of space with the vitality of home. The probes themselves, though built for function rather than beauty, acquire a sort of aesthetic presence when imagined drifting through starlight. Their frames, once polished, are now marked by micrometeoroid impacts and the aging effects of prolonged exposure to space. Their long booms, extended to separate instruments from their electronic cores, resemble arms reaching outward. Their dish antennas, pointed long ago toward Earth and still angled roughly in that direction, appear like pale petals frozen in place. Even in the dark, surrounded by nothingness, they retain a shape and a posture that speaks to their origins as tools of exploration. They are, in a sense, portraits of human ingenuity, moving through a landscape humans may not physically enter for ages. The interstellar medium they inhabit, though quiet, is not uniform. There are variations in density, temperature, and magnetic fields, subtle differences that the probes detect and that scientists use to infer the structure of nearby interstellar clouds. These clouds, immense and diffuse, form the raw material for future stars. Over millions of years, gravity may cause them to collapse inward, initiating the birth of new suns and planetary systems. The Voyagers, drifting near such materials, become part of a larger story, the recycling of matter across cosmic time. Though they themselves will never influence these processes, their presence in these regions adds a sense of connection between human-made machines and the galaxy's natural rhythms. As the years pass and their distance from Earth continues to grow, the probe's motions become increasingly aligned with the galactic frame of reference. The Sun itself moves through the galaxy at around 230 kilometers per second, carrying the entire solar system along. Voyager 1 and Voyager 2, though moving outward relative to the Sun, are still part of this larger motion. They are not leaving the galaxy, they are participating in its flow. Their trajectories form gentle spirals, shaped by the gravitational pull of the galactic center and influenced subtly by the mass of nearby stars. In this way, the Voyagers are following paths laid out by cosmic forces far older and larger than the solar system that launched them. This connection to galactic motion becomes especially meaningful when we consider the scale of time the probes will witness. Over millions of years, the Milky Way's spiral arms will shift position. Star clusters will drift apart. Some stars will brighten while others fade. Regions dense with dust will form new generations of stars, while older regions will become sparse and quiet. Through all these changes, the Voyagers will continue drifting, untouched by the transformations around them. Their endurance transcends the lifespan of stars, stitching together eras that human minds can hardly fathom, and yet, for all this vastness, the Voyagers remain connected to the intimate story of Earth. They were built by human hands, guided by human minds, and launched from a world filled with life, ecosystems, cultures, and dreams. They carry traces of that world on their surfaces and within their records. Their trajectories were shaped by planetary encounters that revealed the beauty and complexity of our solar system. Their transmissions, faint though they are, remain part of ongoing conversations between Earth and its creations. Even as they drift farther away, they are still connected to humanity through memory and meaning. In the coming decades, when the probe's power falls below operational levels, this connection will shift into something more symbolic. Instead of active communication, there will be a quiet awareness that these machines still exist, far beyond the reach of any other object humanity has sent into space. They will become markers of our presence in the galaxy, silent, steady indicators that life on Earth once reached outward with curiosity and hope. Their ongoing drift will serve as a gentle reminder that exploration is not always loud or dramatic. Often it is slow, steady, and deeply patient. These thoughts naturally begin to guide us toward a sense of closure, not an end to the story, but a soft turning toward reflection. The Voyager's journey, though endless in duration, has a shape that invites contemplation. It began with great activity, transitioned into steady travel, and now moves through a phase of quiet endurance. This trajectory resembles the arc of many things in nature: the life cycles of stars, the evolution of ecosystems, the flow of rivers from mountains to sea. Even within the human lifespan, we see patterns that echo this arc: phases of energy, phases of steady progress, and phases of gentle settling. As we continue toward the final part of this exploration, the tone shifts slightly, not toward finality, but toward a deeper calm. We understand now that the Voyager's drift through interstellar space is not merely a scientific achievement, but a kind of cosmic meditation. Their ongoing journey encourages us to think about our own movement through time, our own relationship with distance and change. It invites us to imagine ourselves drifting alongside them, carried by currents older than any memory. The galaxy continues to unfold around them, calm and ancient, as the probes sail farther into its quiet expanse. Their motion remains steady, their presence serene, and their story, though rooted in engineering, has become something poetic, almost spiritual. And as we prepare to enter the final chapter of this narrative, we carry with us the gently deepening understanding that their drift, like all long journeys, speaks softly to the heart as much as to the mind. The Voyagers drift onward through the quiet deep, tracing paths so long and gentle that they seem to dissolve into the background fabric of the galaxy. Their motion is steady, unhurried, and almost impossibly patient, carrying them into realms where the sun, once their warm and guiding lighthouse, shrinks into a familiar but distant point of light. Ahead of them lies only the wide, soft darkness of the Milky Way, lit by thousands of stars whose beams have traveled centuries to reach these small machines. In this final stretch of our shared journey, we walk with them once more through the cosmic quiet, letting their steady drift guide us into a deeper state of reflection, calm and rest. The space around them is so serene that it invites a kind of cosmic introspection. In earlier parts of their mission, their instruments recorded dramatic events: Jupiter's storms flashing with lightning, Saturn's rings rippling with gravitational harmonies, Neptune's wind sweeping across its deep blue atmosphere at astonishing speeds. Those worlds were loud in their own ways, loud with motion, loud with contrast, loud with energy. But now the Voyagers exist in a domain where the loudest forces are subtle shifts in charged particles, delicate variations in magnetic fields, and the faint whisper of cosmic rays traveling across the galaxy. This gentle environment seems to cradle them in a timeless quiet, reminding us that the universe is not always a place of turbulence. It contains regions of extraordinary calm, expanses where even time feels as though it slows. As the Voyagers glide farther away, their relationship with the sun transforms from a physical one to a more poetic one. They still orbit the galactic center along with the sun, but they are no longer bound to its protective winds or warmed by its light. The heliosphere, which enveloped them for the first 4 decades of their journey, now lies behind them like a soft bubble they once lived inside. The boundary they crossed, the heliopause, marks not just a scientific milestone, but an emotional one. The moment when human-made objects stepped beyond the sun's comforting presence for the first time. Even now, imagining that crossing evokes a sense of quiet awe, as though we're witnessing a child taking its first step into a world that stretches far beyond home. Their instruments, though aging, still record the environment around them. Voyager 2, in particular, continues to send back data about particle densities, cosmic rays, and magnetic fields. Each measurement it provides adds new detail to humanity's slowly expanding map of interstellar space. The readings are faint, fragile, and rare, yet they are full of meaning. They come from a place no spacecraft has ever traveled before, a region so remote that even a whisper takes nearly a full day to reach Earth. In this way, the Voyagers teach us not only about space itself, but about the value of patience, of waiting for signals that travel through silence. Silence is a defining feature of their current environment. Out here, sound has no medium through which to travel. There is no air to carry vibrations, no atmosphere to shake with waves. Instead, the universe speaks through patterns of particles and fields, through the quiet interplay of forces too faint for human senses, but perfectly suited to the Voyager's delicate instruments. It is a kind of silence that feels expansive, almost soothing, a silence that says everything is as it should be. This cosmic quiet, paired with the gentle persistence of the Voyagers, brings the mind into a spacious sense of stillness. In such reflections, one begins to appreciate the beauty of motion that feels like rest. The Voyager's speed, tens of thousands of kilometers per hour, would seem immense on Earth, yet out here, it becomes indistinguishable from tranquility. They drift so steadily that their forward motion feels like a slow exhale, a breath released across the galaxy. Their path is not direct, for the galaxy itself rotates beneath them, but it is true, their direction is fixed. Their focus is singular, and their purpose, even in their later years, remains quietly profound. The decline in their power mirrors a natural settling. Their nuclear batteries shed tiny fractions of wattage each year, like embers cooling at the edges of a long-burning fire. Engineers on Earth have long known that this decline was inevitable. They planned for it, adapting the probe's configurations as the available energy dropped. They turned off heaters and instruments one by one, preserving the critical systems for as long as possible, and though the time approaches when the transmitters will no longer have enough power to send signals home, this is not a sudden ending. It is a slow, gentle dimming. This softness makes the impending silence feel peaceful, rather than sad. The probes have already accomplished more than they were ever designed to do. They have traveled beyond the outer planets, crossed the heliosphere, and now drift through a region humanity will not physically visit for countless ages. Their final transmissions will be the natural closing of a long, beautiful chapter. A chapter that began at Cape Canaveral in 1977 and has unfolded for nearly half a century. When they fall silent, they will not be lost. They will simply join the quiet around them, continuing to drift as part of the galaxy's vast poetry. The golden records they carry ensure that in some way, the Voyagers never lose their connection to us. These gleaming copper discs, inscribed with sounds and images from Earth, represent a kind of cosmic message in a bottle, a declaration that life existed here, that it felt joy, wonder, curiosity, and compassion. They include greetings in dozens of languages, the pulse of human heartbeats, the laughter of children, and music from across cultures. They preserve natural sounds, the rustling of leaves, the roll of thunder, the call of birds. They capture moments that might otherwise be lost to deep time, attached to each probe like precious talismans. These records will endure long after the metallic structures of the Voyagers themselves begin to break down. Just imagining these discs drifting through starlight is calming. They spin quietly as the probes sail onward, their surfaces etched with stories that could outlast entire civilizations. Even if no one ever finds them, they will still exist as symbols of hope, tiny treasures moving through a galaxy that has seen billions of years and will see billions more. Their endurance becomes a meditation on the longevity of meaning, on the sweetness of intentionality, and on the possibility that something we create today may echo far into the future. The idea that meaning can drift silently across the galaxy harmonizes beautifully with the Voyager's physical journey. Their ongoing motion embodies a simple truth, that not all paths require destinations. Some journeys unfold for the sake of movement itself, for the quiet beauty of witnessing the universe from a perspective few objects will ever know. The Voyagers are not seeking anything. They are not chasing stars. or navigating toward particular systems. They simply follow the trajectories they were given, trusting the natural forces of the cosmos to carry them forward. In that surrender is a profound serenity. We can follow that serenity inward, imagining the probe's view from their distant perspectives. If they could see, they would glimpse stars positioned quite differently from the constellations familiar on Earth. The sun would appear as one bright point among many, warm in memory, but small in the sky. Around them, stars would move slowly, shifting positions over millennia as they follow their own courses through the galactic disk. Meteoroids and dust particles occasionally brush past the probes, but such encounters are rare, separated by years or centuries. Most of the time, the Voyagers drift through pure emptiness, where the nearest particle may lie kilometers away. This emptiness is not harsh. It is gentle, clear, and uncluttered. A space where the concept of urgency disappears, and in this disappearing, the mind finds room to soften. Thinking of the Voyager's path becomes similar to imagining oneself floating in a quiet sea, held by calm currents that ask nothing of you, offering only the reassurance of steady movement. The heart rate slows, thoughts loosen, the body relaxes into a feeling of weightlessness. The Voyager's journey becomes a metaphor for rest, the realization that drifting is not a sign of being lost, but of trusting the flow around you. As we imagine this drift, another truth emerges, that the galaxy is not chaotic, but deeply ordered. Its spiral arms turn like vast, gentle rivers of stars. Its interstellar clouds form patterns shaped by physics that unfold with the elegance of slow breathing. Gravity acts as a quiet sculptor, guiding the motions of stars, dust, and gas. Cosmic rays surge from distant cataclysms, but even they follow structured paths defined by magnetic fields. Everything has room, everything has rhythm, and the Voyagers, though small, are woven into this cosmic choreography as naturally as a leaf floating in a wide lake. The probe's presence in this grand structure encourages us to think about time in a new way. When they eventually pass near other stars tens of thousands of years from now, the Earth will be unimaginably transformed. Landscapes will shift, ecologies will evolve, human cultures will grow, change, and adapt. Yet the Voyagers will continue steadily through all of it, untouched by these transformations. They will trace a path not bound by decades or centuries, but by epochs. This extraordinary endurance makes their journey feel peaceful, like a reminder that some motions stretch far beyond the short cycles of daily life. In contemplating their endurance, we also consider the endurance within ourselves, the quiet resilience that carries us through long seasons of change. The Voyagers were built to be sturdy, reliable, and adaptable, yet they were also built with intention, launched into the cosmos with purpose, curiosity, and wonder. These same qualities exist in every human being: the desire to explore, the instinct to seek meaning, the longing to reach beyond the familiar. As the probes drift deeper into interstellar space, they reflect back to us the parts of ourselves that move through life with patience, openness, and quiet courage. And so, as this final chapter unfolds, the Voyagers guide us toward closure, not abrupt or final, but gentle and contemplative. The farther they travel, the more their story becomes one of quiet continuation. They have left behind the solar system's warm cradle and stepped into the galaxy's deep calm. There is no urgency in their motion, no destination that presses upon them, only the slow, peaceful glide through a cosmos older than memory, older than Earth, older than any dream humanity has ever dreamed. You can imagine the final moment of communication years from now, when their faint signals reach Earth for the last time. The radio antennas listening for them will capture a whisper, perhaps diminished, perhaps fragmented, but still radiant with meaning. It will be a final message across an unfathomable distance, a last triumph over silence. And then, the transmitters will fall quiet. Yet the silence that follows will feel natural, like the soft darkness after dusk, or the gentle stillness that settles before sleep. In that silence, the Voyagers will become eternal travelers. They will continue drifting through the galaxy with the same steady grace, their golden records glinting faintly in the starlight. They will pass through regions shaped by the birth and death of stars, through clouds of dust that may someday form new solar systems, through spaces so calm that even cosmic time seems to slow its breath. They will drift long after Earth's mountains erode, long after its oceans shift, long after its skies transform. Their paths will become threads woven into the tapestry of the Milky Way. As we follow them in our thoughts, their tranquility becomes our own. The idea of drifting through space weightless, timeless, surrounded by quiet starlight, creates a sense of peace that settles over the mind and body. The Voyagers offer a vision of rest that is not anchored in stillness, but in motion that feels like stillness, a rest that is deep, continuous, and gentle. And now, as the journey moves toward its soft conclusion, let yourself imagine the view from their distant positions. The stars shimmer across the dark like tiny lanterns, each carrying a history older than human imagination. The sun glows behind them, a warm memory. The galaxy unfolds before them, wide and welcoming, and the Voyagers, unhurried and untroubled, continue on with quiet certainty. In this image, there is a sense of completion, not because the story ends, but because it continues on so gracefully. The Voyagers will never stop. They will drift forever, becoming part of the calm architecture of the galaxy. Their motion becomes a lullaby, a soothing rhythm that invites you to rest, to breathe softly, to let go of the day's concerns. Their journey reminds us that drifting is natural, that rest is part of the universe's design, that peace can be found in motion as easily as in stillness. And as you reach the end of this story, you can follow their example, allowing yourself to drift into the soft, expansive quiet that waits at the edge of consciousness. Thank you for journeying through the cosmos tonight, floating with these small, faithful travelers as they glide beyond the reach of the sun. May their endless drift bring you comfort, ease, and a deep sense of wonder. And now, as the Voyagers continue into the star-filled darkness, carrying Earth's golden whispers with them, I wish you a warm, peaceful rest. Good night.